Alright folks, today we're going to do a worksheet specifically on light, and we're going to move pretty quickly. Give 3 examples of electromagnetic radiation that has higher frequencies, shorter wavelengths than visible light. If it has higher frequencies, that means it has higher energy, it's more damaging. So that would be ultraviolet light, and we do that because, remember, we wear sunblock to protect us from ultraviolet light. We have X-rays, which are far more damaging. We have gamma rays, which come from the sun, and we have cosmic rays, which also come from the sun. Okay. 3 examples of electromagnetic radiation that have lower frequencies, so they have less energy, they have longer wavelengths. So the one that's closest to us is infrared radiation. The next one is microwaves, like in our microwave ovens. Now you might think that those are more damaging, okay, but really they're not. Microwaves, because there are so many of them inside a microwave and it's so intense, that's why they cook food. Okay, and the last one that I would say are radio waves, and those can be AM radio, FM radio, etc., cell phones, all that kind of stuff. That's all down there. Television, that's all down there. Okay. All right, what's the range of visible light in nanometers? It's about 400 nanometers up through 750 nanometers. Okay, and because these are wavelengths, so wavelengths, and so the wavelengths here are shorter. So these are your violet light, and up here these are your red light. Okay, the use of polarized glasses clearly proves that light is a wave. Remember, we had polarized glasses where we said that they had essentially slits in them that were very close together that looked like this, and we had other ones that looked like that, and when we put the two of them together, it blocked all the light, so we could demonstrate that light was in fact a wave. As frequency increases, wavelength decreases. Okay, that means that they are inversely proportional. Okay, so if you think about it, the speed of light is equal to frequency times wavelength. So as one of these goes up, to keep C the same, like if this went from 1 to 2, and this was already at 2, then this would have to go down to 1, so that in both cases 1 times 2 or 2 times 1 would be a total of 2. So when one goes up, the other goes down. That means they are inversely proportional. Of the visible light spectrum, what color of light has the highest frequency? That's, again, not something you should memorize. That's something you should just be familiar with, so that you could say, well, which one would have the highest frequency? The one with the highest energy. Which one's going to hurt you the most? Oh yeah, that's our ultraviolet. So that means violet would be the one that would be the most damaging, and red would be the one that is least damaging. And so which one has the longest wavelength? If it has a long wavelength, then it has a lower frequency. So this would be the one that did not hurt us. So that would be red. All right. In your own words or in pictures, define amplitude, frequency, speed, and wavelength. Well, let's first just draw a wave. All right, here's a wave. That's pretty good with one of these pens. All right, so your amplitude is from here to here. That's your amplitude. Just going to mark that with an A. It is from the top all the way down to the origin. You could do the same thing here and say it's the distance there if you wanted to. Frequency. Let's look at frequency first. Let's do these in order. Okay. This wave is far more frequent than the one on the left. Okay. It hits you less often if the waves are traveling at the same speed. And since we're talking about speed, the speed of light is 3 times 10 to the 8th meters per second. We said that's about 186,000 miles per second. So it's very, very, very fast. All right, and it is constant, so it does not matter what the frequency of the wave is. The speed of the wave is the same. Okay, so the one on the right is more frequent, the one on the left is less frequent. And what is wavelength? Wavelength is typically from crest to crest. You could measure it from the bottom to the bottom of the next one. Those are called troughs. That's okay as well. All right, but you're essentially going crest to crest or bottom to bottom. Okay, that is it. We'll see you in class. If you have any questions, let me know. See you then. Bye.